Good morning, guys. Please introduce yourself.
Hello, good morning. I'm Pavan and I'm from Hyderabad.
Okay, good. And few more people are there. Let me know your names and native place.
Hello, sir. I'm Balu from Siddipet.
And one more thing, let me know your education qualification.
I'm Balu. I'm completed my BTech in the branch of Tripoli in 2023 pass out.
Good, Balraju. What about Pawan?
I have master's in computer science, which I finished in 24.
Good. Good, Pawan. Let's wait for a while. We'll start our session. Okay. Those who are joined now, let me know your names and qualification and proper places. We'll start our session at 11:05. Okay. I need response. Can anyone? Sorry. Okay. Good, Kailash. This is the best way to start your networking journey right now from the CCNA. Yeah, definitely. I can guide you in a better way. Well, everything, each and everything will be taught here. Uh, Up to the interview questions, all the what are the different questions can be asked. All those things will be. So I will let you know in upcoming sessions, each and everything. Okay. If you have any queries, come to the chat box and type the message what you want to say. Okay. If you feel okay. Oh, nice to hear it, Manoj. It's a good one. But I mean, Windows server. Good. Well, so this is the best one. I mean, best way you can get into the network side by taking the CCNS. Good morning, Sohail. Is my voice is audible? Please do response.
Yes, yes.
Good. Okay. Can we start the session now? Okay.
Yeah.
Raju. Okay. Pawan, are you there? Okay. Okay. All right. Let's begin our session. Good morning, everyone. Welcome to the CCNA course. My name is J. Ranna. I have 1 year of experience working as a network administrator. I'll be teaching you the CCNA. Let me briefly introduce you to the organization and our course CCNA. I will share to the screen. Yes.
Yes, sir.
Is my screen audible now? I mean visible?
Yes, sir.
Let me.
Yes.
Yes, yes. Okay, good. So Zoom Technologies. So Zoom Technologies has established back in 1996. Okay, which provides networking and security solutions to the different clients across the globe. Okay, and you can see here are the services we provide. Security Operation Center, we can, in short, we can call SOC, and vulnerability assessment and penetration testing, we can call it VAPT testing, and ADR. Please unmute, mute. And one more thing, we give dark web monitoring and digital forensic services and data recovery services. So these are the different services provided by our organization, Zoom Technologies. Okay. And you can see here clients. We have different clients all around the world. So we have from through the RBI, sales, DCNs, DRDO, and for the Telangana and AP Police, we have gave the services and security solutions. And for the Indian Railways, we have provided the van technology. Okay. So we have different clients all across the globe from the India and other countries also. So for any kind of issues relating to your training, which include downloading the recorded sessions or logging, you can contact me or counselors. And we have at level 3 Srinivas sir. You can contact them. Whatever you can note down this details. For any issues, you can contact us. Have you taken the screenshot or else? Let me know. Yes. Okay.
Yes, sir.
Yeah, good. And let's discuss about our course CCNA. Okay. Right. Okay. CCNA. Right. My screen is visible, right? Okay.
Yes.
Let me. So have you ever heard the word, I mean, CCNA? What is CCNA? CCNA, right? Okay. CCNA stands for the Cisco Certified Network Associate. Okay. So those who are trying to start their career as a network in the networking path, they can choose the CCNA, right? So have you known the what is Cisco? Cisco. What is Cisco? So Cisco is a US based company which manufactures routing, I mean networking devices like routers, switches, and firewalls. Not only networking devices, it also manufactures, provides software solutions like Cisco Packet Tracer for the purpose of laboratory to practice. Okay,
Can you please load us?
little bit louder.
Yeah.
Okay, okay. Cisco is a US based company, okay, which manufactures networking devices like switches, okay,
Excuse me, sir.
Yes.
Sir, is this course will cover this CCNP also, sir?
Yeah, part of CCNP also be covered. Protocols will be
Okay.
discussed in this. Yes.
So complete
Configuration.
CCNP, it will cover complete CCNP, right?
Not complete CCNP. There will be a slight part which is in the, I mean, the protocols like OSPF and STP. These protocols will be discussed in the CCN. In this, we will discuss which are the
Oh,
concepts in the CCNP. Okay, those
okay.
configurations.
So, by
Yes,
with the knowledge of this, sir, we can work as a level 2 IT support, sir.
level two. No, level two basically considered as the one who has the experienced one, but we can join as a level one.
Okay.
Yeah, for the level two, we require the experience.
No, no, not. I'm not talking about experience, sir. Leave the
Yeah,
experience, but with the knowledge of this CCNP,
yeah, you can do
which you
this.
will provide.
You can do the thing what the level two person can does.
Okay. Well, sir,
You will
what is
have
this Cisco security, sir?
Cisco security.
So
Yeah,
it is also important to cover in the level 2 IT support job, sir.
yeah. Cisco security is basically to provide the security for the networking devices like this routers and switches.
Okay, okay, sir. Thank you, sir.
Yeah. So it manufactures switches, routers, and firewalls also. Firewalls. Okay, and also provides software solutions. Wait a minute. Software solutions. Okay, like we have the Cisco packet tracer for the purpose of doing the labs. I think many of you heard this thing, right? Cisco packet tracer. And once we begin with the configuration part, we will know how to do the things configuration part in the Cisco packet tracer. I will show you how to do the configuration, switches, routers, okay, and local area network. Okay, let me open one more thing, one more slide. Okay, here you can see the examination, CCNA certification examination. The examination number is 200301, but the duration is 2 hours 120 minutes, and the number of questions asked between the 50 to 60 questions they might ask. Okay, depending upon the difficulty level, the questions will be vary. Sometimes they will ask the 55 questions, sometimes 60 questions, like that. And the passing marks are 810 out of 1000. And the available language is English. And one more thing we need to discuss here, the exam questions. It might be multiple choice question, single answer or multiple answer. And there will be a drag and drop type of questions also will be there, and simulations, and scenario based. General scenario based, we can say he just gives a scenario. Based on that, we need to configure things out there in the examination. Okay, is up to here clear? Okay, Cisco offers not only CCNA, it also provides 4 more different certifications. In this, we have CCEN, CCNA, and CCNP, and CCIE, and Cisco Certified Architect. Okay, this is the topmost level. Okay, you can see here CCENT. CCENT stands for the Cisco Certified Entry Networking Technician. Basically, right now, Cisco has retired this certification. Means they generally merged this into the CCNA. Okay, we're coming to the CCNA. As you all know, CCNA stands for the Cisco Certified Network Associate. Okay, in this Cisco Certified Network Associate, we can discuss topics like it covers CCNA. In the CCNA, we will discuss topics like IP addressing, and the next one is um, basic security, subnetting, routing, switching, VLANs, and NAT, access control list, and basic security, and wireless network. All these things will be discussed in the CCNA part. And coming to the CCNP, this is a professional level. We can call it as professional level. Professional level. Okay. In this, those who want to explore some more deeper in the networking, they can go with the CCNP. Right now, whatever the things, some of the portion will be covered in the CCNA. I will be teaching you whatever the portion, somewhat portion covered in the CCNP, I'll be teaching in the CCNA only. Okay. And coming to the CCIE. In the CCIE, it's the expert level. Expert level, this is okay. Those who are having good experience with the networking, they can attempt this examination. It will have a like around 8 hours of examination, which includes the laboratory examination also. We need to perform well in this and we can get the certification. In simple words, we can say this is the most reputed certification in the networking part. And the architect level, the topmost level is architect level. So in this, the main major purpose of this, the person who is the architect, he designs the whole network and what kind of the devices need to use, which router, which switches, okay, and what are the security things need to be provided to the devices. All these things can be done by the architect. He designs the whole network. Okay, clear with the all these certifications? Let me know.
Yes.
Is there
Okay.
any time gaps between the certification to certification after completion of CCNA to attempt for CCNP? Is there
Okay.
any mandatory, we need to showcase this many years experience such like that? Immediately after also we can go for the CCNP training and give the examination. The
Yeah,
same way like
coming to the
CCIE.
examination, talking like in the point of examination, we can say that CCNA, it validates up to 3 years the certification. No, you can give the attempt. If it's required, you can give
Okay,
the attempt.
immediately, yeah, CCNP also we can take the examination and give that attempt,
But
right?
as of now, whatever the things there, some of the things will be taught in the CCNA only. I will be teaching you those configurations also. Okay.
Understood.
Yeah. All
Is
right.
there any different types of certifications in CCNA itself,
No, no, no.
or
In the
only one
CCNP,
examination?
yes, only one examination. Okay.
Okay, I mean to say that switching, routing is and the security separately. All together is one examination.
All together.
Yeah.
Okay. And so once you're done with the CCNA, we have some of the career opportunities like network support engineer and network administrator, and we can join as a system and network engineer also. System and network engineer is nothing but the one who is okay with the Windows server, Linux server, and upskilling themselves to the networking side. They can join as a system and network engineer also. And we can also join as a technical support engineer level 1 and level 2. Also, we can join. Okay. After completion of the CCNA, for this role, we can apply. All right. Okay, shall we begin our networking journey?
Yes.
Okay, all right. So, I want to let you know some of the key terminologies, some basics key terminologies in this. Okay. If you have any notes, maintaining any notes, please note down basics terminologies. Okay. The first one is, we can say, network. Network. So what is network? Can anyone define? And whatever the things you know, just reveal it.
Connection of computers, sir, through a wire or
Yes.
something.
Yes, yes.
Okay, sir.
It's correct. Yeah. Interconnection of two or multiple devices. Okay. Network is nothing but interconnection of two or multiple devices, we can say as network. So what's the purpose of network? What is the purpose?
To share the information between two computers or between two networks.
Yeah, absolutely correct. The purpose is mainly sharing resources, sharing resources, and for the smoother communication, smoother communication. And one more thing, we can say, for the purpose of utilizing the internet resources, right? Accessing resources from the internet. Okay. Resources type like what? What we mean? Generally, I want to let you know one small example. So let's say there is a bank. I think many of you know the SBI branch. I mean, have you visited SBI branch? Some kind of bank. Okay. Let's say I'm considering here SBI bank. SBI bank. What we had, we see generally there is a manager cabin, right? And one more thing, we'll have the accountant's cabin. Are you able to see everyone?
Yes,
And loan
yes,
provider.
yes.
Yes.
Okay, good. Loan provider. So what generally they have? They generally have some PCs, right? Like manager having one PC, and accountants. Let's say they have two systems in front of them, and the one who loan gives the loan approves the loan. Okay, and one more thing, there will be a separate printer, right? I think many of you have heard the sound, printer sound. Always it prints something, some kind of copies will be printed in this. Let's say this is a printer. So in the back end, what happens? Each PCs, internally, all these PCs are interconnected, each and everything. Okay, all these PCs are interconnected. They might connect it to a central, switch, right? So what's a network? Network is nothing but interconnection of two or multiple devices. The purpose of network is to share the resources, utilize the resources, whatever the present, and for the smoother communication between device to device, we can call network. You can see here that right now we have the physical connectivity between the manager device to the accountants, from the accountants to the loan provider, and from the loan provider to printer. All these are devices are connected to some centralized device. Let's say this is a switch. Okay. For this device, this piece is made connected, and printer are also connected to this switch. So now if managers want to access something or he wants to print something, he uses the printer, right? He uses the printer. If accountants want to print something, he also uses the same printer, and the loan provider as well as. So this is the purpose of network. And the next terminology I want to let you know is networking. Okay, what is networking? Networking is nothing but enabling the communication. Enable communication between the interconnected devices. Okay, enabling the communication between the interconnected devices. So right now you can see here we have the physical connectivity, right? Which the manager PC and the accountant's PC and the loan providers connected to the switch. This is a switch. For the switch, they are connected, and the printer also connected to the switch. Now, to enable the communication between these interconnected devices, we use the called terminology networking. Okay. Okay. And one more thing, in the CCNA level, we're gonna discuss 4 modules. The first one is, note down this one. In the first one, we will discuss about the basic fundamentals. Basic fundamentals of networking. Okay. In the second module, we will discuss all about the routers, their internal components, external components, and whatever the protocols we are using, and different types of routing like static routing, dynamic routing, and their configuration part. All this thing will be taught in the second module, it in the IP routing. IP routing. In the third module, we'll discuss about the LAN technology. LAN technology. Okay. In the LAN technology, we will discuss about the mainly switches. Okay. Switches. In the switches, how to creating VLANs. Okay. And the different protocols present in the switches like DTP, and we have the VTP and STP protocol. STP protocol. Different types of protocols will be discussing in the LAN technology, which is the third module. Coming to the fourth module, we can say network security. Network security. In this module, we will discuss all about how to prevent our devices. Okay, providing security to networking devices. What are the devices we have? Like routers, switches. Okay. And we will discuss about some of the concepts like access control list, who can access our local area network, and who can stop, and I mean who can access the whole thing, and the kind of authorization we can provide here. And also we will have the DHCP configuration, how to assign the IP addresses automatically to the end devices like personal computers in a network. All this thing will be taught in the network security portion. And coming to the routers, what if in case if we forget the password allotted to the router? In simple term, we can say password recovery. Password recovery. Okay, these are the 4 modules we're going to discuss in the CCNA part. Okay, in the IP routing part, we will discuss about mainly routers. Okay, so within the after completion of 3 to 4 sessions, we will diving into the routing portion. All right. Up to here, clear? Anyone? Please do response.
Yes, sir.
Okay, good. You can see here the device schedule. See, in the first 4 days, 3 to 4 days, we are going to discuss about the basics of networking, and tomorrow and day after tomorrow we'll discuss about the IP addressing different types, IPv4 and IPv6, and upon the next we'll discuss about the OSI layer. Okay, and after that we'll discuss basic router connectivity and initial configuration, and after that we will discuss the whatever the things like protocols we had in the routing part, working on the IPv4, and introduction to dynamic routing and static routing, and protocols like OSPF and RIP protocols. Those things will be taught in the routing portion. Okay, if you want to note it down, you can note it down, or you can view it in the well, you have the presentation. This whatever the presentation is there will be present in the Zoom Technologies site. You can check it out there. Okay. So after that, we are going to discuss about the switching, and after completion of the switching part, we will discuss the security portion. Okay. Here you can see what is default routing and NATing, network address translation. What's the purpose of that, and HSRP, IPSLA, and local authentication. We can discuss all these things, password recovery, and backupping the configuration, whatever we have done in the routers. All these things will be discussed after day by day. We will discuss, cover all these concepts. Okay. So this is the overall. Yes.
Can you present the previous slide once?
Previous slide. Okay. This one.
Yes.
Okay. And we will discuss about the main one thing, subnetting. What is subnetting, and different types like FLSM and VLSM. All these things will be discussed in this course. And OSPF, we have the single area and multiple area. We will see the major difference between these also. Okay. Shall I move to the next slide?
Yes, sir. Yes, sir.
Okay.
Yeah.
All right.
Please.
You can see in the switching portion. See, in the switching portion, we will discuss the initial configuration of the switch, and VLAN and trunking. I will let you know this while we are discussing about the switching. And we also have some of the protocols in the switching, DTP, VTP, and port, providing the port security for the switches, and creating the ether channel. I'll let you know all these things in the switching portion. After that, we have the security. Okay. In security, we will discuss what is access list. We have two kind of access control list. We will discuss the different things in that. And after that, we will discuss default routing and NAT. And some of the advanced concepts also will be taught in this. Okay. This is the main thing is password recovery and backup of iOS. Okay. This is the main thing. So let's start. Basics of networking. As you all know, network is nothing but interconnection of two or more devices is called a network.
Excuse me, sir, I have one doubt.
Yes.
Sir, actually, can we do practical in this course, sir? Because we need the wires and all these things, devices.
Yeah. Yes. Yes, you can do it by, but virtually, I mean, we have the Cisco Packet Tracer is a simulation software.
Okay.
We can do practice. So whatever the physical connection is there, we will do in the virtually, we can do this connectivity. I mean, these
Okay.
labs. We will
Okay.
configure in there, and we can do things. Whatever the things done in the physical manner, I mean, in
Yeah.
the real time,
Yeah.
those things will be performed virtually here.
Okay. Okay, sir. Thank you.
Okay. Each and every configuration will be taught by me. I will
Okay.
teach you.
Okay, sir.
Yeah. So what's the main purpose here? Network. Interconnection of two or more devices is called network. And to enable the communication between these interconnected devices, we call the terminology networking, right? explained this to enable the communication between the interconnected devices. Nothing but networking. So establishing the connectivity between devices with the help of either hub or using the switch or wireless access point for the communication purpose. Okay. Connected between the device with the help of hub, switch or access point. Okay. And I want to let you know two more terminologies. One is inter network. Okay. Have you heard this terminology, internetwork? What is internetwork? Internetwork is nothing but same interconnection of two or more networks. Okay. Interconnection of two or more networks. Right? What it means. Let's say we have a brand. So I think all of you from the Hyderabad, right? I mean within the Telangana. Okay. Let me know. So I will take a sample example to get this into your mind. Please do respond.
Yes.
Okay.
Yes. Yes.
Okay. Let's say we have a branch. Yeah. To get this into your mind, I'm taking a small scenario. Listen here. So what's the thing is that internetwork is nothing but, let's say we have a branch at Secunderabad SBI branch. Secunderabad SBI branch. Okay. So this is a one network. We can call this is a one network. And there is one more network. We can say Hyderabad SBI branch. Okay. And one more thing. Well, let's say Siddipet SBI branch. Okay. Now, connecting these three branches together, we can call it as, with the help of a networking device, let's say router, we're connecting these branches together. All these three together, we can call it as internetwork. Okay. And next, one more terminology is internetworking. Internetworking is nothing but, right now we have the physical connectivity between the different branches. One is at Secunderabad, one is at Hyderabad, and another is at Siddipet. Somehow we have connected these three branches. Okay. Right now we have only physical connectivity. To enable the communication, to have the communication between the Secunderabad and Hyderabad, from Secunderabad to the Siddipet, and from the Siddipet to Hyderabad, and Siddipet to Secunderabad, we call it to enable the communication, to enable communication between the network. We call it as networking. Is that clear now? Shall I move to the next slide?
Yes.
Okay.
Yeah.
Okay. What are the four key terminologies? Network, networking, internetwork, and internetworking. These are the four terminologies we need to remember as we are going into the network portion. I mean networking part, right? Let's see types of network. Okay. So in the types of network, we have local area network, metropolitan area network. In short, we can call it as MAN. And for the local area network, in short, we can call it as LAN. And wide area network. and wide area network is nothing but we can call WAN. Okay. Next, let's say about LAN, local area network. You can see here, local area networks are used to connect the interconnection of PCs. Note down this, connect the interconnection of PCs and other network devices that are very close together in a limited area, such as a floor of a building, or in a building there will, within a room, within a floor, within the whole building, we can call it as LAN, local area network. Or in own terms we can write it down, interconnection of PCs and networking devices within a limited area. Within a limited area. Okay. Interconnection of PCs and network devices within a limited area, we can call it local area network. All right. You can see the animation here. So we have an organization at Banjara Hills. Let's say within a floor, we are having the organization where the connection of the PCs to the networking devices you can see here. So this is a switch where PCs are connected to switch. Okay. This is a small kind of network. Or we can say, for the understanding purpose, the branch, as earlier mentioned, SBI branch, right? SBI branch. Okay. It's also a kind of LAN, local area network. Why I'm saying it's a local area network? The reason is it is in the limited area. Well, the whole branch you can see, it will be within a floor. Okay. Maximum it will be within a floor. Or if it is to the larger extent, it will be within 2 floors, like that. So we can call it the whatever the interconnected devices, the connectivity, we can call it as local area network. Understood? Next, MAN. MAN stands for the metropolitan area network, are used to connect networking devices that may span around the entire city. What it means, let's say we have a city, Hyderabad city. Okay, Hyderabad city. Let's take 2 places. Like say any of you let me know any 2 places in Hyderabad. Yes.
Gachibowli,
Gachibowli. Okay, right.
Secunderabad.
Amirpet.
Banjara Hills,
Good. Gachibowli, Amirpet, Banjara Hills. Okay. So let's say you have an organization at Gachibowli and one at Amirpet and one at Banjara Hills. Okay. Or we can suppose you can consider the SBI branch. There is a SBI branch at Gachibowli, SBI branch, and Amirpet you have the one more SBI branch. Okay. There also one more, and at Banjara Hills also is one more. Okay. Interconnecting all these 3 organizations, like it's a kind of organization, right? Interconnecting all these 3, we can call it as metropolitan area network, which spans within a city, the Gachibowli, Amirpet, and Banjara Hills, which are situated within a city, Hyderabad city, right? So this metropolitan area network is nothing but interconnection of different local area networks which spans within a city. Okay. This is all about the metropolitan area network. Got the point? What is metropolitan area network? So
Yes.
whatever the organization present within a span of city, these organizations can be connected. That's the main point of the metropolitan area network. We can call it that network as a metropolitan area network. The next one, you can see here. Wait a minute, I will erase all this thing. Okay, so we have this is a Hyderabad city. We have one organization at Banjara Hills and one more at Amirpet. Okay, this is a separate plan. This one is separate plan, right? Separate local area network, and this is also a separate local area network. We are connecting these two organizations with the help of man. What the point? We are connecting these two
Yes.
organizations with the help of metropolitan area network. Let's see WAN, wide area network. WAN stands for the wide area network, which connects two or more LANs present at different geographical location. Try to understand here different geographical location. You can see here the animation. So we have two different LANs, right? One at Hyderabad and one is at Dublin, which is situated in UK. This is in the place called in UK. Okay, and this is in India, right? Okay, so nothing but connecting these two organizations. The one is at Dublin and Hyderabad. We can call it as wide area network. Using the different intermediary network devices, we do connect these two organizations. We call it as wide area network. Once you can read it out, that wide area network which connects two or more LANs present at different geographical locations. Next, internet. It connects millions of computers together globally, forming a network, which forms a network in which my computer can communicate with any other computer as long as they are both connected to the internet. So what happens? So when you type generally something like if you want to reach out Google or a Facebook page, what do you do? Just you go to the browser and type the FB or Facebook, whatever in your own slang you type. Generally you type, and you will reach out the Facebook login page, right? So we can call it. You reach out the Facebook server, general, using the internet. You can see. So you are sitting in a Hyderabad. See, you are sitting in the Hyderabad and you are generating a packet. Suppose to explain this one, let's say you are sitting here. This is a PC one, personal computer one. You are sitting here and trying to access fb.com, facebook.com. What happens? The packet will be generated here and it will be forwarded to your respective switch. From the switch, what is the from there to the router, and the router to the whatever the intermediate routers goes to the internet. In the intermediate router, it forwards the packet. Okay, how it reaching the facebook.com, we will study in the upcoming sessions. Okay, how the packet is forwarded to the other routers and what kind of protocols are used in between these routers. Okay, all these things we will discuss in the upcoming sessions. And the next one is topology, network topology. So what do you mean by topology? What do you mean by topology? Anyone?
At least geographically, right? Topographical maps refer to sort of layers upon layers
Yes,
of land.
in the
So here it's
networking.
probably for networks.
Yes, simple way we can call it physical or logical arrangements arrangement of devices. Okay, understood? physical or logical arrangement of the devices. Devices like what? PCs, routers, switches, and other devices. Okay, like that. So in this topology, we'll discuss about the 4 different types of topology. We have bus topology, and the next one is ring topology, and the third one is star topology, and the mesh topology. Okay, I have created slides here. You can see. So see, bus topology. The first one is what we had in the first one, bus topology, right? Let's study what is bus topology. Let's map in the pieces here. Whatever this is a basic diagram of bus topology, how it physically connected. You can see. Let's map it this as the 1, or we can make it A, and make it this as B, and the upper one make it as C, and here D. Okay. So we had a centralized cable here. This cable, we generally call it as backbone cable. Backbone cable. Okay. Generally, this cable is coaxial cable. Have you ever heard this cable, coaxial cable? Generally, in your house, you have the
Yes.
TV connection, right? So there is an antenna coming from the, yes, Srinivas?
Yes.
Okay, okay.
Coaxial cables which is connecting to the
Setup box.
our cable TV setups.
Yes, cable TVs and setup box. So that cable is used here for the purpose of the connectivity. Okay. Suppose if A wants to reach out C, what happens? A wants to reach out C. So here the data is, I mean, there is a kind of frame or packet is generated here, and this packet will be forwarded to the this centralized channel. We can call it a channel. Via this channel, the transmission of the data will happens. Channel, centralized channel. Okay. What happens? So when a data packet is generated from A, it reaches out this channel, this backbone cable. From the backbone cable, it reaches to the respective destination. Okay. In the packet, generally it has, we will have the, what is the source and destination. What is the source and destination addresses will be created, generated. Okay. During the packet generation, we can call it. Okay. This is the bus topology where we're having the one centralized channel. Via that channel, the data will be flow. Okay. What if in case,
Sir,
if the yes,
I have one question, sir. This bus topology, will it be connected in WAN or LAN? In which area network, sir? Within the organization or?
yeah,
Mm.
generally it is outdated actually.
Okay.
Outdated. I
Uh-huh.
mean, to know how data flows here, I'm discussing that
Okay. Okay,
it's
sir.
outdated. See,
Okay.
due to some reasons, there is a fluctuation happened in the centralized channel. Okay.
Okay.
Okay. Fluctuation happened and it went down. This cable, this cable went down. So then what happens if A wants to, A is trying to reach out C, either um, does A reach out to C? No, right? As the cable is
No,
broken down here, right? So it won't
no,
reach
it
us
is not
to
able
C.
to.
Yes. So no communication will be done. No communication. And one more thing, as it is a single channel, okay, centralized single channel, right? We can call it, there is a one major disadvantage of this is single point of failure. Single point of failure. If the channel is gone down, we won't communicate with other devices present in the same organization, right? That's a one more disadvantage we can call it out. And what happens? See, there is, let's say now the channel is, I mean, where is it here? Okay. Now it's in the coaxial cable is up. Now A is trying to reach out C and B is trying to reach out D, this D. What happens when the data packets are generated? Okay, when it reaches the centralized cable, there might chances of collision. One more thing, chances of collision is high. Chances of collision. Okay, so this bus topology is almost outdated. We won't use this one. Okay, this is all about the bus topology, how the data is transmitted using the centralized cable. This centralized cable, we can call it as backbone cable. Okay, clear here up to here?
Yes, sir.
Okay, next moving to the ring topology. Okay, ring topology. So in the ring topology, what happens? The flow of data will be in clockwise direction. Okay, I will show you the animation once the theory part is completed. I will show you the animation, how the data will be stored. Okay, let's say mark down this as A and this is as B and this as C and this as D. Okay, if A wants to communicate with C, what thing happens here? Same here, the packet will be generated. Okay, in this packet we have the source and one more destination. Okay, source and destination addresses will be there in this packet. So what happened? So in simple term, we can say the ring topology is nothing but connecting to its neighbor. So there is a C. A is connected to B and A also connected to D, connecting to the neighbors. But the data flow will be always in the clockwise direction. If A, there is a packet generated from A, it's want to reach out the C. So in the source, what's the address we have? A. In the destination, we have C. What happens? So when the packet is generated, it moves, the packet will be forwarded to the D. From B, the B will forward the packet to the B will forward packet to the C. This is how the data will flow in the ring topology, one after the other. We have some of the disadvantages of the ring topology. Disadvantages. What's the one major disadvantage? What if in case the system B is in shutdown mode? Does the packet is forwarded to the C? I need your response, please. Anyone reply?
No.
No.
No, right. The packet is won't forwarded to the C. That's the one major disadvantage. One is intermediate devices. Oh, okay. And there is a one more major disadvantage. What if in case the cable is failed? Okay. Then at the moment also we'll have, I mean, the packet will be won't forwarded to the next devices. Okay. If the cable is down. Here the main thing you need to understand is how the data is flowing. What if in case, I mean, what are the disadvantages in the ring topology? Okay. And coming to one advantage it has is there will be no collision. No collision. Because they need to wait for a time. particular time. After that, if if A wants to communicate with the C, if A communication is happened, okay, the packet is received from the C, it got the reply back, okay, reply back, and the next one B wants to communicate with the C at the same scenario. One after other will the communication happens. There will okay. So, yes, which is called device. That this device, what happens? Let's map D and E. Okay. See here. With yeah, okay. Okay. This response
Sir, your voice is not audible, sir.
at
And
least
the screen also stopped.
in the chat.
So we cannot hear you, sir.
Hello. Now now you are able to hear.
Yes, sir.
Okay. Everyone, please let me know.
Sir. Yes,
Okay,
sir,
now.
now it is audible.
Yeah, good. Able to see the screen now?
Yes,
Yes,
sir.
yes.
Okay, all right. I think there is a small internet issue here. There's a reason. We have the thing. Okay. Star topology. Let's discuss the star topology. Let's map it this as the A, B, C, and the D, and this as the E. Okay. Now, if A wants to communicate with the B, what happens? The same. A's PC will generate a packet here. It has a source address, and a destination address. We will discuss what is source address and destination address in the upcoming session. Tomorrow is the one of the in the Monday. In the Monday session, we will discuss about the IP address. In that, we will discuss what will be the destination and what will be the source. All these things will be discussed in that. So if A wants to communicate with the B, what happens? Same, the packet will be generated. And the packet is generated, it will be forwarded to the switch. Okay. From the switch, depending upon the destination address, it forwards to the respective destination. Okay, and here the major advantage, and this topology is used basically in the organizations. So whatever the organizations you see, generally they go with the star topology. Okay, their devices will be connected to a switch, from the switch to the router, router to the ISP, the one who provides the internet. Okay, we can call it ISP as the internet service provider. Understood? This topology, this star topology used in the organization level, or we can call it enterprise level. Able to hear now? Enterprise level. Okay, let's talk some of the advantages of this. Advantages. What's the major advantages we have? If some other devices like E, D, and C in the shutdown mode, shutdown, still we are able to communicate with the B, right? Still we are able to communicate. Able to communicate with B. And there is a one disadvantage, major disadvantage of this star topology is what happens if the networking device, what is the device here? What device we can call it as? This is a switch. Okay. What if networking device switch went down? Switch is down. Now, am I able to communicate with the B?
No, no.
Right. Yes. So this is called again single point of failure. Single point of failure. We will discuss what then, sir, how it will. I mean, in an organization means it is quite costly if the whole network goes down, because the organization is spending somehow money, right? So we will have a backup path. So we will discuss all about this in the LAN technology third module. In the third module, we will discuss in detail about this, how we have the backup redundancy path and how we enable that. Okay, all that thing will be discussed in the third module. Okay, in coming in the switches module, we'll discuss how we have the redundancy path and how we are able to enable it when the major link is down or major networking device is down. Okay, all that thing we will discuss in the switching portion. Okay, the main disadvantage is single point of failure in the star topology. Okay, this is a centralized device. Got the point?
Yes, sir.
Yeah. Next, coming to the mesh topology. Okay, in the mesh topology, each and every PC is connected to other PC. Okay, so see here, this is A, market A, map it A, B, and C, and D. So D is connected to A and to B and C, and A also connected to B and D and C, and B also connected to the D, C, and A. Okay, so there is a connection between all the devices. In the mesh topology, we can say connection between all devices. All devices. So Right now we have how many devices here? 4 PCs, right? 4 PCs. How many ports we require to to have the communication mesh topology network?
3.
3
3.
ports required. Yes, 3 ports required. But what's the scenario? Does we have 3 ports for the PC? Ethernet
No.
PC? No.
No.
We only have
No.
one port. The Ethernet port is only one Ethernet port we had, right? But so is this possible for us to connect having multiple connections? What if in case your network having 100 PCs? Okay, then what's the cable expensive? The cable expensive is high. You require cable, right? Because you need connection between all devices. Cable is expensive. And one more thing, shortage of ports, we can say. So all these are the major disadvantage of the mesh topology. Okay, this is all about the topologies we have. Okay, these are the 4 topologies. What are the 4 topologies we have? The first one is bus topology. The second one is, let me
Ring.
know, ring topology.
Ring.
Yes, ring topology. And third one,
Star.
star topology. So generally we go with the star topology in the enterprise level. Okay, and the fourth one is mesh. Mesh topology, each and every device is interconnected. So right now this mesh topology we use in the routers like Wi-Fi routers. Have you heard Wi-Fi routers? There will be D-Link router or TP-Link routers will be there in the organization. So there we use the mesh topology. Virtually they are connected. Okay, via Wi-Fi. This is all about the topologies we have. You can see the animation now. The bus topology. You're seeing, right, how the data is reaching to the destination. It generated in the, see, this is how it reaches the data, the communication. And the next one is ring topology. The data will forwarded in the clockwise direction. Okay. And the star topology. What happens in the star topology? Let's say if this is A wants to communicate with B, what happens? The generated packet moves to the switch. From the switch, it moves to the respective destination. Same. If this is a D and this is C, to enable to have the transmission of data, what happens? From the C, packet will be, from the D, packet will generated and moves to the switch. From the switch forwards to the respective destination to the C. This is how star topology works. And next, mesh topology. We have multiple backup paths. Okay. If one path is down, it chooses another path to reach the destination. Okay. Is that clear?
Yes,
This
sir.
is all about the network topologies, how the data will be moved, the flow of the data will be like this in the different topologies. Let's see setting up a network. Okay, note down everyone. Setting up a network. Before starting the setting up a network, I want to tell you one more thing. With this, we can generally start our troubleshoot. So when you are when you are joined in a organization as a network admin or a technical support engineer, or we can call the system and network engineer. When there is a troubleshoot, what you need to do? You need to start your troubleshoot from this. The first one is network interface card. We can call, in short, we can call it as NIC card. Okay. The moment when you are facing any issues in the network, you need to troubleshoot it, right? Then you need to start the troubleshooting from the network NIC card, network interface card. We can call it as Ethernet card. And the next one is media. Either the physical connectivity is okay, or if there is any failure in the physical connectivity, we need to check it out. Then we can find out if the physical connectivity is okay, then we need to move the next one. Network devices. Is the network devices functioning properly? Is the protocols are configured in a, I mean, if the protocols are configured properly or not? Okay. And the further we will discuss in the tomorrow session two more things. One is IP address, and OSI reference model. We can call OSI layer. Okay. Got the point? So this is the path you need to follow when you are troubleshooting something in a network. This might helpful when you are troubleshooting. You need to check first the NIC card, which is present in your PC. I think many of you have the RJ45 port, right, for to your PCs. Let me know.
Yes.
Yeah, we generally
Yes,
can
yes.
call it as a NIC card or Ethernet card or LAN card. Okay, we need to start troubleshooting from there. And next is the connectivity. Whatever the connection you had from your device to the network device, the physical connectivity, media, cable, we need to check the cable. In the media, we will discuss about the cable. Here, we will discuss about the cables, different cables. And in these network devices, we'll discuss about switches and one more thing, routers. Okay, we need to check the configuration of the switches. If anything is not went proper, we need to configure it back. And the next one is routers. In the routers, we need to do the configuration. Is the protocols are in the enabled position? Whatever the things we need to do it there. So these steps will be helpful in the troubleshooting part. Okay. After that, if the network device is performing well, then we need to check the IP addresses. Okay, whatever the IP addresses we have assigned, we need to check whether they are good or assigned properly or not. And the next one is OSI layer. We will discuss all this within the span of 3 to 4 classes. Okay, in the tomorrow session, we will discuss about the IP address. Let's discuss what is NIC card. Okay, NIC card. Wait a minute, guys. Network interface card. In short, we can call NIC card, right? So NIC is the interface between the computer and the network. What do you mean by interface? Simple, for the purpose of understanding, we can call it as mediator. NIC card. Okay. So when you're typing something like sitting in your so you're opened a browser and you have typed something in the Chrome, let's say facebook.com. What happens? These NIC cards will forward the traffic to the network. Okay. It also known as a LAN card or Ethernet card. Generally, so someone like right now, Manoj, I think Manoj has worked as a Windows administrator, right? Manoj, please do respond. Yes. Okay. All right. So interface is nothing but which act as a mediator. Generally, uh, we have a let's say we have a PC, and in the PC generally we have one of the software operating OS we can operating system. In the systems we have the PCs, personal computer, we have operating system. This operating system let's say for the Windows is a kind of operating system. So which act as an intermediary between the PC and the hardware. Okay. The same thing here. NIC card act as the interface between the computer and the network. Whatever the traffic is generated, the traffic will be moved out of your PC from this NIC card. It is also called as LAN card or Ethernet card. And you can see here for the Ethernet card, which means this NIC card, have a 48-bit unique IP address called as MAC address. Okay, now it's visible. Ethernet card have a unique 48-bit address called as MAC address. Media access control. So MAC address is also called as, what do we say?
Access control.
You can see here. MAC address is also called as a physical address. You need to remember what is MAC address. They might ask you in the interview, what do you mean by MAC address and where do you find it out? Then you need to answer it that generally we find out in the NIC card. Okay. Or we can call it as also hardware address. Okay. We have the two kinds of addresses. One is physical address. And one more thing is logical address. These are the two different addresses available for us. Okay. Where you can find the physical address to the LAN card or this NIC card. Okay. This will be the 48-bit unique address. The 48-bit MAC address is represented as 12 hexadecimal digit. Note down this. The 48-bit MAC address is represented as 12 hexadecimal digit. You can see the example here. I will let you know what is hexa binary conversion. I mean binary and binary representation and decimal representation and this hexadecimal representation and octet representation in tomorrow's session. On the Monday, we have a session on IP addressing. In that session, I will let you know each and every point what is hexadecimal representation and the binary representation. All these things I will let you know there.
Excuse me, sir.
Yes?
Sir, MAC address is similar to IP address, sir?
No, no, no.
Okay.
It's a physical address and IP address is a logical address.
Okay. Okay.
Yeah. Physical address is a MAC address. Logical address, you can call it IP address. Okay. We will see about the IP address in the Monday session. Okay. So here you can see the 12 digits, right? 12 hexadigits. So this 10 is represented in the form of like 0, 0, 0, 0, and this one also 0, 0, 0, 0, and the 1 as 0, 0, 0, 1, and the 6 as 0, 1, not 1, 1, 0, 1. You can see how it will be represented. Okay, all these things we will see in the tomorrow session in the IP addressing portion. Next, these NIC cards has different available in the different speeds. This NIC card. So in general, it looks like this. This is the RJ45 slot. Okay, where you can find out to your PCs if you have those systems like which belongs to the 11th generation, 10th generation. You can find out this. For this right now, updated. I mean 12th generation systems, and for this system right now they have disabled this one. They are only using the Wi-Fi card. Okay, wireless card. We have two types. The one is Ethernet card, and the another one is wireless NIC card. Okay. So from the 12th generation, they have just installing with the motherboard this wireless NIC card. So we are connecting with the Wi-Fi like that to the internet. Coming to the here, these network cards, Ethernet cards have the different speeds. The Ethernet which has a 10 MB per second, and the fast Ethernet cable, okay, 100 MB per second, and the gigabit Ethernet which has the 1 GB per second. You need to remember this in point of examination. You need to remember Ethernet, how much speed does it possess? Okay, allows. It allows 10 MB per second. And the fast Ethernet NIC card, it allows 100 MB per second. Gigabit Ethernet, 1 GB per second. Okay.
Excuse me, sir.
Yes.
This network cards are available in Wi-Fi also, sir.
Yes, that's the reason we are connecting to the Wi-Fi NIC card.
So where can we see, sir, in router or that card, sir?
No. Right now we have the motherboard, right, for our systems.
Yes, sir.
They are integrated with that.
Okay, we give the connection. No, I'm
Ah,
asking like how the Wi-Fi is working, sir. Is there any network cards in that or?
yeah. To need to understand this one, we need to check out the whole, I mean, how the motherboard is there and where the this wireless NIC card is positioned there in that.
Okay. Inside the motherboard, we can see this NIC card.
Yes, internally it will be integrated. Okay.
Okay.
Yes. This is all about the NIC card, and in this 48-bit address, right? As earlier mentioned, how many bits? It's divided. It is 48-bit address. You need to remember this. So you can see the next slide. These 48 bits, altogether we have 48 bits. Okay, these 48 bits divided into 24 bits and another 24 bits. The first 24 bits will basically identify the vendor. Okay, let's say in mobiles, what we have different vendors like let me know vendors like we have Oppo, okay, Redmi, Samsung, and iPhone, right? These are different vendors. Okay, for making this NSE cards also we have different vendors. Okay, the first 24 bits will be represents the vendor, which vendor is made this NSE card, and the next is NSE card identification number. We can call the next 24 bits will be helpful for the identification of the card. Understood this? The first 24 bits will be basically with the 24 bits we will identify the NIC card belongs to which vendor. Okay, and the next 24 bits we can identify the NIC card. Let's say to understand this, generally there will be a, let's say, one college, IIT Hyderabad, right? So in the ID, what happens? The student, there will be student ID for each student ID. So they will mention that IIT Hyderabad, and the student ID card, let's say he belongs to the 25th batch and his serial number is some 117. This will be his ID. So the first 24, these bits will represent the, he belongs to IIT Hyderabad. And this belongs to the, this represents the student ID. Okay, this one. Understood? The same thing in the NIC card. The first 24 bits will represent which vendor prepared the NIC card, and the next 24 bits will be what is the ID number of the NIC card. I want to open chat once. Any doubts up to here? Okay, no doubts. All right. Coming to the media. So the major purpose of media is to transport the bits. So right now we have discussed came from packet. The PC will generate a packet, right? Whatever the packet is generated, it will be always in the zeros and ones, ones and zeros like that. Okay, nothing but these are in the bits. These bits will be transported via cable media. We have two different kinds of media. We'll see here. So what's the major purpose of the media? To transport the bits from one machine to other. So we have guided media and unguided media. In the guided media, we use physical cables. Physical cables. Okay. In the unguided media, nothing but using the radio frequency, or we can say infrared waves. Okay, unguided media is nothing but it doesn't follows any path, particular path doesn't follows. Here we have the physical cables. In the guided media, we have the physical cables. Via the physical cables, the bits will be transferred from one machine to the other machine. In the unguided media, it uses radio frequencies, radio waves. So in the guided media, we have the coaxial cable and twisted pair cables and fiber cables, fiber optic cables. Okay, I want to let you know about each and everything here. What is coaxial cable and twisted pair and fiber? And the next one is in the twisted pair. Further, we have unshielded twisted pair. This is UTP is nothing but unshielded twisted pair. And this is shielded twisted pair. Okay, and this is a fiber optic cable. And in the unguided media, we have infrared waves and radio frequency waves. RF stands for the radio frequency, infrared waves. Okay, let's discuss about the coaxial cable. Coaxial cable. See here, the basic definition of coaxial cable is a coaxial cable where it basically whatever the bits are there, those bits were converted into electrical signals with the help of NIC card. So what's the purpose of NIC card? NIC card converts the whatever the bits coming from the PC, those bits will converted into the electrical signal based upon the media, whatever the media. If it is a wireless, the bits will converted into the Wi-Fi. Okay, waves. Radio waves. If the media, NIC card is, if the media is physically connectivity, then it will connected into electrical signals. Okay. A coaxial cable is an electrical cable that transmits electrical signal consisting a central conductor. This is a central conductor. You can see here. This is a central conductor surrounded by an insulating layer. Insulation. So what's the purpose of insulation here? To stop the leakage of the electric signal. It won't allow the signal to the outside. And there is a copper mesh. This prevents the electrical noise from interfering with the signal. So whatever the noise is there, okay, generally in the we have many waves, radio frequency waves are there, right? So what's the purpose of this mesh is it generally prevents the unwanted voice. From the unwanted voice, it will protect this electrical signal will be protected. And in the outer we have this black one. Okay. Next, coming to twisted pair. So is the types of cabling that consist of pairs insulated wires twisted together to reduce the electromagnetic interference. What is interference? Nothing but unwanted noise. Okay, a twisted phase. Basically, this will reduce the unwanted noise coming into the signal. We have two types. The first one is unshielded twisted pair, which most commonly used within the LANs local area. Within a local area network, we generally go with the unshielded twisted pairs. Okay, pairs of wires twisted together to reduce electromagnetic interference. Okay, there will be no extra shielding around these pairs. Okay, and which is a cheaper one and easy to install and flexible, used in the Ethernet. All right. Is there any doubt up to here? See, I want to explain one thing here. So let's say this is a PC. Okay, let's consider this is our laptop. There will be a NIC card present for this. Okay, let's say you are connected to a switch. You're connected to a switch, and this switch is connected to a router, and this router is connected to some ISP router for the internet. ISP router, let's say. So what happens? So when the packet is generated in your PC, if you had a physical connectivity, the NIC card, here we have NIC card. Depending upon the medium, what happens? Right now we have physical connectivity, which means NIC card, what it does, it converts the bits, whatever the coming bits, converted into electrical signal or light signal, or if there is no physical connectivity, if it is unguided media, then what happens? This NIC card converts the bits into waves. Okay, that's how what happens in backend, and it reaches the respective switch if it's a physical connectivity. If it's a Wi-Fi, then it reaches the Wi-Fi routers. Okay, so we have the unshielded twisted pair in this twisted pair, which is basically used in the LANs, and pairs of wires twisted together to reduce the unwanted noise. And for this, unshielded means there is no extra shield around the pairs and used in the Ethernet. Next one is shielded twisted pair. In the shielded twisted pair, we have extra shielding layer is there. Okay, you can see, I will show you the diagram how it actually looks, and compared to the UTP, it is compared more expensive than UTP. Okay, used in with heavy interference like data centers. In the data centers, whatever the cables were used, they are the shielded twisted pair cables are used between the devices. You can see here, there is an extra shield here, you can see, right? And you won't find anything here. This is the difference between the STP and UTP cable. This is the one major difference between the STP and UTP cable. All right. Yes, anyone, please respond.
Understood, sir.
Yeah.
Okay. Yeah. All right. And the next one is fiber optic cable. So to explain this fiber optic cable, simply what happens, the NIC card converts bits into light waves. Okay, NIC card converts bits into light waves. So here the data transmitted in the form of light waves instead of electrical signals. Light signals in the form of light signals, the data will be transferred to the other machine. You can see in the fiber cable, we have the core portion, and the one more is cladding. Yes, you will have different type. No, no, no. Wait a minute. I will see the chart once. Okay, so we will have different type NIC card for UTP, STP, and fiber cable. No. See, for the guided media, suppose what I earlier mentioned, you can see here. You can see here. Here, if there is a physical connectivity to the switch, what does NIC card converts the whatever the coming bits into the electrical signals or light signals. It converts the whatever the coming bits are there to the NIC card. NIC card should convert the into electrical signals or light signals. If this is coaxial or twisted pair cable, what happens? The bits will convert it into the electrical signals. Electrical signal. If this cable is a fiber optic cable, if the NIC card will convert into the light signal. Okay, understood? This comes under the guided media. Guided media means physical cables. If there is no connection, direct connectivity, there comes the wireless NIC card. This wireless NIC card, what it does? It converts the bits into waves, radio frequency waves. Okay, understood now? Kailash, are you able to get it? If we had a physical connectivity, then the bits will be okay. Hear me again. See, if we have a physical connectivity, then what happens? The NIC card will converts the bits into either in the electrical signal or light signal. If there is no physical connectivity, if you are connected to a router, then what happens? You are trying to reach out a, let's say, take the scenario. You are trying to reach out facebook.com. You are connected to a Wi-Fi router. The packet is generated. It comes to the NIC card. Now your NIC card is connected to what? Wireless media, right? Wi-Fi router is a wireless media. There is no direct connection. Then what happens? NIC card converts this packet, I mean these bits, whatever the bits coming to the NIC card, into the radio waves. Got the point now? If there is a connection, then the bits will convert it into electrical or light signals. Yeah. Got the point? Okay. All right. So this is, you can see the
So,
generally is the
what I understand, hello, sorry to interrupt you, sir. What I
yeah.
understand from Kailash's question is that, so in a PC, do we have different types of NIC cards? Different types of NIC cards means in terms of STP or UTP, you will have one type of card. For fiber optic, you will have a different type of product.
No. See.
And for wireless, you will have a different type of NIC card.
No.
So if I'm wrong, it is correct. Please correct me.
Yeah, I will correct you. See, you can see here. Okay, media, right? In the media, we have guided media. Okay, leave the NIC card. Okay, NIC card portion just leave for here, and there is unguided. Okay, in the guided, we have the physical connectivity. For the physical connectivity, we have three different kinds of cables. One is coaxial cable, is a physical cable, right? You can find it out in your home. Coaxial cable. And the next one is twisted pair cable. Okay. And the next one is fiber optic cable.
Yes.
Wait a minute, I'm coming there. Just listen here. So there is a system. Let's say there is a system. your system having a NIC card. If to the NIC card to some other networking device, if it belongs to, if this cable is a coaxial cable, we will have different types of NIC card, Wi-Fi NIC card and this Ethernet NIC card. I mean, normal LAN card, and one more Bluetooth NIC
Yes,
card
sir.
also we have. If see
Yeah,
here,
this is what his question. Yeah.
this is an NIC card, right? For this NIC card, I
Yes,
have
sir.
connected coaxial cable. Now, what does NIC card converts the whatever the coming bits, the packet is coming right to this in the form of bits. These bits will converted
Yes.
into the electrical signal
Electrical signal.
as it need to move via the copper wire, right?
Yes.
So the purpose of NIC card is nothing but it acts as an intermediator between the computer and the network. That's the meaning of NIC card.
Yes.
Here, if it is a
Yeah.
fiber optic cable, what happens? It converts, the NIC card converts the bits into light
Into
signals.
light signals.
Yes, that's
Yes.
the point. Now got the point?
Yeah.
If
So
there is
for
no
each type of media, which type of media you are selecting, based on that type of NIC card will be there.
yes.
If it is
No,
coaxial cable,
NIC code will
one
be
type
not
of
there.
NIC card.
NIC code converts in NIC code converts into
Yeah.
that signal.
Particular, yeah.
Yeah. Oh, you see,
Based on the type
coaxial
of
cable.
media what you are using,
Yes.
NIC card will be used.
Coaxial cable only support electrical signals. So, and what NIC card does?
Yeah.
NIC card converts the bits into electrical signal. And
Yes.
fiber optic cable only supports light signals.
Yeah.
It uses a total refraction. It's a kind of thing. It's a in the other side. It uses light signals. So what NIC card does? It converts the bits into the light signals. If there is no connectivity, it's unguided media. You are connected. I mean, connected to a Wi-Fi
Lot of
router.
signals.
Am I able to hear?
Yes. Yes.
If you're connected to a Wi-Fi router, which is unguided, then what NIC card does? Wi-Fi NIC card does transmit these bits into the waves in the forms of waves. Okay.
Yes.
That's the work of NIC card. And here we are using this. Okay. And one more thing. So in the unguided media, we have infrared and radio frequency. Okay. You can see here. I think you know about the infrared waves. Example, the simple example for this TV remote. Okay. So which have a very shorter range. These are in the form of waves. And the next one is radio frequency. Radio frequency, generally we can call it as example Wi-Fi. Okay. These are we won't have any physical connectivity, virtual connectivity there with the routers, like example Wi-Fi routers. Virtually we are connecting. Okay. Got the point here? We have in the unguided media, we have infrared waves and radio frequency. To understand the infrared waves,
Yes,
we can say TV remote. So when you are at the pointer, we can call it a line of sight. Line of sight means you need to be there near to the TV. Okay, right now there is a upgradations in the TV remotes, like it's using Wi-Fi and some of the remotes will be using Bluetooth right now. But in the earlier days, we need to go near to the TV and then we need to press the buttons, whatever the navigations we need to do, we need to press those keys, right? So we can call it line of sight is required in the infrared waves. Okay, This RF is nothing but radio frequency waves. Generally, we can say for understanding purpose, Wi-Fi routers. Okay. This is all about the media. The major purpose of media is to transport the bits. Okay. Here. To transport the bits. Okay. Everyone come to the chat session once. I'll post you something. Fill up this form once, everyone. Kailash and Srinivasu, Manoj, Pavan. Come to the chat session. I just have posted one link. Click it and fill the form. Yes. Patel. In the tomorrow session, we will discuss about mainly about IPv4. Okay, IP addresses. What is IP address? What is the requirement of IP address? And we'll have the in-depth about the IP address. Okay, and what are different types of IP address we have right now. Okay.
I've filled up the form. I didn't get a confirmation of any sort.
Oh, you haven't get any confirmation, right? Okay. Let me know. Wait a minute. I will be back.
Sure.
Just a minute. Good, Srinivas. I have seen that. Counter chats. Okay, done. Good. Very good. So remaining members also finish it off. So
Excuse
that
me.
is yes.
Excuse me, sir. Sir, if we reside in another country, is the fee same or different, sir?
It will be up to the counselors. They will let you know.
Okay, okay.
You will
Thank you.
you can contact the counselors. If the
Okay.
details are required, I can share you now.
No, no, actually, I'm in India. I was asking for my friends, sir. So it's okay. I will
Okay.
ask them.
Yes.
Sir,
Yes,
can you
Patel.
provide your number, sir? If we stuck in the lab or something, we can contact you.
Yeah, absolutely. I can provide you number.
What is your name, sir?
Viranna.
Okay, okay, sir. Thank you, sir.
Yeah. Yeah, Pavan. One more thing. I will post my number here. Contact number. You can contact me.
Yeah, it will be great, sir. Sir, one more thing I have to ask. Right now I'm in
Yes.
India, but
Okay.
this month I'm going to Saudi Arabia. So this the time we will meet daily at 2 o'clock or 11 o'clock.
Sorry. Please repeat it again. Please repeat
So
it.
right now I'm in India, but I've talked to a counselor also. This month I'm moving to Saudi Arabia.
Okay.
So this time will be fixed or it will be changed?
Timings are fixed. The
Okay.
timings will be the same.
Morning 11 o'clock.
Yes, morning 11 o'clock.
Mm.
So, for any queries, generally uh, the who are working with the um, website, they will create a general tunnel, a kind of session will be created.
Okay.
Okay. If you had any doubt in that, we can solve it. Okay.
Okay.
In part of configuration, whatever the things.
Okay.
Yeah.
And
Pawan,
can you confirm that my form is submitted or not? Because it's not showing that it's submitted.
acha, okay. Hmm, wait a minute. Yeah, Pawan. So the forms were submitted.
I'm sorry, did it go through? It got submitted?
Yes.
Okay,
Um,
perfect.
so this work belongs to the counselor and those who are handling backend, maintaining their website. They will
Right.
get to know all these things. Okay.
Yes.
Okay. All right. That's nice one. Okay. Let's have one more small concept here. You can see here. I have shown you already. These are the UTP cables. And for the STP cables, you can have the shielding. Okay. This is the coaxial cable, how it looks. I think many of you have seen this one in your home. These are the fiber optic cables, how they are located. Looks like. So here you have straight through cable, crossover cable, and rollover cable. Okay. LAN cable types. You need to remember LAN cable types is what. Okay. Straight through cable. Let's have what is straight through cable. So straight through cable is used between two different devices. Try to understand. Used between two different devices. What the point? Let's say you are having PC to connect to the switch, PC to switch. We use the straight through cable. Okay, between two different devices. PC is a different device and switch is a different device, right? There we use the straight through cable. If you want, am I audible?
Yes.
Okay, yeah. And the next one is, let's say switch. We have a switch and a router. To connect switch to router, what kind of cable we use? Different device, right? Switch is a different networking device, and router also a different networking device. There we use straight
Straight cable.
through cable. Yes. Cable. Crossover cable. So this crossover cable is used between the same devices. Same devices. Let's say PC to PC. If you want to connect PC to PC, we use which kind of cable? Crossover cable. PC to PC. Okay. And if there is this kind of switch, if you want to connect switch to switch also, what kind of cable you need to use? Crossover cable. Devices like switch to switch, router to router. Okay. When we have the same devices, we need to use the crossover cable. Same devices. Rollover cable. Coming to the rollover cable. The rollover cable generally used for the purpose of configuration. You need to configure a router switch. There you use the rollover cable. Okay. For the purpose of configuration, we use rollover cable. So these are the three different types of cable we have. Okay. This is how the fiber optic cables actually be there. Core cladding and outer jacket. And in a twisted pair cable, we have Cat5, Cat5 enhanced, Cat6, different categories. And the data transmission rate. DTR is nothing but data transmission rate. Okay. For the Cat5, we have 100 MB per second. Okay. And which is connected to the RJ45 connector. And Cat5 enhanced, we have the data transmission rate is 500 MB per second. These all are the cables. Okay. You can see here twisted pair cables, different types. Cat6 cable, which has a speed of 1000 MB per second, which means via that cable, we can go with this speed, 1000 MB per second speed we can reach through the other machine. Okay. Is that clear? Please give the response.
Yes, sir.
Okay,
Yes, sir.
Patel. Okay, Patel and Srinivasu, good. In the tomorrow session, we will discuss about the types of IP. Kailash, yeah, good. Good to hear. Types of IP. Okay. We will discuss in depth. So on the Monday session, we will discuss about the IP addresses. What are the different types of IP addresses? Okay. How it is differentiated, all these things. Okay. I think that is the message I had. Wait a minute. Session? No. We don't have session on Sunday. Okay. So tomorrow is the Sunday. We don't have the session. On Monday, so the same timings, we have the session. Okay. Try to attend the Monday session because it covers the IPv4 maximum IP address, which is one of the most important topic. We need to understand what is network bits, host bits. We will discuss in depth. Okay.
Excuse me, sir.
Yes.
Sir, will you give these slides, sir? PPT presentation slides.
Yeah, you can find this in the Zoom technologies. I mean, so once you contact the counselors, they will provide you credentials. You can access these slides. Okay.
And do you have a lab material for this, sir?
Yes. You can also access the lab material.
Okay, sir. Thank you, sir.
Yeah. contact the counselors. Should I display the details once more? Yes. Can I display it one more? The details. Yes, Patel.
So if we have zero knowledge of networks, you we will get from trash to everything.
Yeah, from
We'll
yes,
cover it in this.
yes, everything you will get to know
Okay.
each and everything.
Okay.
IP address. See, if you're a beginner, you'll get to know. Wait a minute. The fund for this. So we'll get to know IP addressing and next one, different type of IP addresses, IPv4, IPv6, and the next step, what is subnetting, where the subnetting is used. Next step. After completion of that, we have a OSA layer. What is the purpose of OSA layer? After that, we will discuss about the router, external components, internal components, and the configuration protocols, and different types of routing, static routing, dynamic routing. And further, after completion of that, we will discuss about the switches, how the switches works, and what is the main role it plays in an organization level, each and everything, and how can we protect our switch, and how can we protect our router in the security portion. What if in case if we forget passwords, how to record the password recovery. Okay. So as a network admin, you just set up a network, right? And after a while, if you forget the password, how to record from that and how to restore whatever the configuration you had. Generally, you do a lot of configuration, right? Those configurations can be also, we can save. All these things we can learn in this, from the scratch to the better. Okay. Each and everything you will come to know.
Okay. Thank you.
This will be, you can contact. Okay. Okay. Is there any doubts up to here?
Clear, sir. It's clear.
Okay, good, Srinivas. And if you had any doubt, let me know.
No, sir. Right now we don't have.
Yeah, good. In the Monday session, we are going to discuss about the IPv4, which is one of the most important because as we need to work with the help of the IP addresses, so we are discussing in depth, all about the IP address in the Monday session. Okay. Okay, all right. Now you can leave the session.
Thank you, sir. Thank you.
Thank you.